All right, so two things to mention today. So I've got two topics to go over before I get started with today's in-class exercise, which will be the majority of our of today's exercise. Today's exercise should be a bit fun as well, and you should be able to work together in groups for this. So please, feel free to get friendly with the people next to you as this goes on. But I just want to be clear a couple of things up. So this is not something I care about, but it's something I feel I need to address because a bunch of you are fall freshmen, and thus meaning this is your first semester. So it's email. Basically, when sending an email to a professor, generally the way to go about it is professor last name. That is the safe, not wrong way. Okay. And the reason I bring this up is that I've gotten a couple of emails directed to me as Mr. Benjamin, which is, I don't care, first off, but Benjamin's my middle name, so that's a very interesting thing. And I just want to give you a heads up before you tick off the wrong professor. Like, I don't care. I'll just let it go until you I guess, crumple within from embarrassment for realizing you got it wrong. But again, it's generally you want to do professor and then whatever name. You use doctor if and only if you know that they've got a PhD, an MD, or some other terminal degree. Generally, though, I don't think Juris Doctors or lawyers go for adding doctor to the name. Don't know why. It's a professional thing, I guess. But generally, you only add doctor if they've got only add doctor if they've got a terminal degree. And again, only if they would prefer to be addressed that way. So professor, whatever, is generally a good choice. So those are the safe way to do it. The other way to do that, there's this tendency where you're going to where a lot of students write out a long informal email, and then you'll typically get a response from a professor that's like a few words long. I find that pretty funny, actually. But email is generally, just simply be with the email to get what you need. Generally, just put what class you're in somewhere. So what I like to do is in the subject line, okay, is to do something like if I boot up idle for a second because I'll need it in a bit, okay. And you see this in the emails I send out, and this is just something I like it to be something along the lines of course name, right? Be it CIS 1051, and then I just put the subject over here, whatever the subject is in your email. And this basically asks for what you need, like if it's an extension or whatever that you're requesting, okay? Anyway, that's basically the, otherwise, it's not too, don't be afraid of reaching out to your professor via email unless it says in the syllabus. Don't do that. Although you should be able to do that. I'm pretty sure that's the standard way of getting in contact with your professors. Anyway, it's not something I care too deeply about, despite me spending 3 minutes on it. All right. So the next thing is that I want to go over something I should have gone over Tuesday, and as we were going through the in-class exercise, I realized, I forgot to bring this up. Which is and I said I'd come back to it, and I didn't, which is the equal sign, right? So we learned, to review, what did we learn on Tuesday? We learned that there's that we are concerning ourselves currently with 3 data types. There's more data types, but for right now, we're concerning ourselves with just integers, which are your easy-to-use numbers that we're all so very familiar with, the whole numbers, positive or negative. Your real numbers, or as we call them, floats. Other languages call them doubles. Those are the ones that have a floating point in them, right? Nothing to be scared about there. And then finally, there's strings, which are denoted by either using a single quote, right, or a double quote to say, okay, I don't want you to interpret this literally I don't want you to interpret this as a variable. This is literally text. It is a string of text. There is one other way to do a string in Python, which is pretty unique to Python, and that is the triple quote, which is to use either 3 of these or 3 of these. Multi-line and you'll see over here that it's got, this is a /n, multi-line /n, string /n, and you should have, and hopefully you learned in your first lab what that /n means. /n is a control sequence, and what that means is that basically when the computer, the interpreter, or compiler in the case of other languages, sees that backslash, sees this symbol, it says, hold up, that the next thing, this denotes there's going to be a special symbol that I can't normally type, like hitting the enter key or hitting the tab key. Make sense? So this says, go to the next line, right? So that if I were to store this in a variable, okay, if I were to take this, whoops, let's see, why is this not going? Oh, because it's spanning across both strings, okay? So if I were to take this string that we typed out, put it in X, and print X, that would print out, and this is a multi-line string, just like that. So those /n's in here get converted into something like that. But honestly, like, putting this in is sometimes a pain, and it doesn't look nice, right? So that's where this comes in, right? I could do something like X is equal to, and that's a bit nicer to read. At least I think so. Right? This is not something you'll be tested on, the multi-line string. It's not something you have to worry about on exams. You're not going to even have to really use it in your classes. Sorry, in this class. It's just something that you might see, and so I'm making you aware of it. Okay? So I try to focus less on Python-specific features. I'll bring them up as we come across them, but I try to do things that are generally applicable for every programming language, something that you can take from one language and easily apply it to another. Okay. So we learned about our 3 types, and what we've learned is something that I'll be drilling into you for the next couple of semesters. Okay? The way this works is you take the thing on the right and store it in the variable on the left. That's what the equal sign does. So if I say x is equal to 5, that copies 5 into x. Okay? Okay? Now if I say y is equal to x, that says take the thing on the right, evaluate it, and store it in the variable on the left. In other words, figure out what the thing on the right is and store it on the left. That's what it does for this. It figures out, oh, that's 5, so I'm going to now store it in the variable on the left. So it figures out x is 5 and stores it on the left. So if I print y, it's 5. Makes sense so far? No confusion here, right? Take the thing on the right, store it on the left. Everybody got that so far? Okay. This is where I want to make sure I don't lose people during this part. So now I'm going to do this. X is equal to 6. I say equals to, but in reality, what am I doing? I'm saying figure out what the thing on the right is. It's 6. Take it and store it in the variable on the left. Think of it as like this is a box, and I can only store one thing in that box. So there was a 5 in it. Now I'm going to store a 6 in it. Okay? I'm just replacing what the value is. X is equal to 6, unsurprisingly. Y is not equal to 6, it's equal to 5. Because I took what was I figured out what the value of the thing on the right was and stored it on the left. I'm not balancing scales. I'm not setting a hard binding between y and x. I'm simply copying what's in x and storing it in what's y. And the reason we do, so it doesn't necessarily work the way you'd think it would if you're coming from math, or intuitively you might think the equal sign works. And the reason being is that because God help you if you write a large program where we've got a bunch of variables set to each other or relation to each other, and then you change one, and then you'd have to remember what all those changes, how those changes would cascade. It'd be a lot of mental bookkeeping. This kind of bookkeeping where we're just taking one thing and copying it over makes a lot of sense, right? Suppose I'd instead defined y as, can you think of the mental nonsense that would have to do if I instead defined y as x plus 1, figure out what the thing on the right is, x is 6, plus 1 is 7, store it in y. So we store 7 in y, right? And then if I said x is equal to 10, right? That would be really complicated if I'd have to remember, okay, I've set x to 10, that means y is going to be 11, right? That would be really, really complicated. No, the assignment statement says I'm going to take 10 and store it in x, not that I'm creating a hard binding between anywhere I saw x, it's now going to be equal to 10. X is now 10, and it's going to remain 10 so long as I have any say in it. And y's value, it was 7 because, again, we figured out what x was. It was 6 plus 1, right? It happens, and remember, it's because it's just going to be reading these commands one at a time. Okay? So that's the main thing about this. Now, the reason I bring this up is that because in computer science, you'll often see a phrase that looks like this. X is equal to 10, right? So just to remind you what that value is, you'll often see something written like this. X is equal to x plus 1. Or what we call the increment operation, right? And this looks nonsensical, right? If you saw this on a Facebook page saying, you'd be saying like the math had been wrong, right? Or if you saw this in math class, you'd be like, oh, gosh, I made a mistake somewhere. No, this is perfectly valid in programming, because here, right, this equal sign is the assignment statement. It's more like an arrow like this, only this looks like less than double negative x plus 1. So that doesn't seem to make sense. Then if I did this instead, it looks like less than or equal to, right, instead of an arrow. And this just seems, and that's 3 keystrokes, and that's 2 keystrokes more than I want to do. Some programming languages, as I mentioned, used to use something called the walrus operator, because if you turn your head sideways, it looks like a walrus with his little eyes and his tusks over here, right? So just simplify that to x, and it makes, and once we spend like the 5 minutes we did on it, hopefully it makes sense, right? X is equal to x plus 1. So we figure out what the right side is, which is 10 plus 1. And then we say, okay, I've figured out what 10 plus 1 is. It's 11, and I'm going to store it on the left, which means now this becomes 11. Everybody follow that? Did I go too quickly? You'll be seeing this, more when we get into loops, and as things need to be adjusted in loops. But this is just something you'll see, and I just want to make sure you understand that this is not exactly equals to, even though I'll be saying equals a lot. Okay? Now, today's exercise hopefully should be a much more fun and longer exercise. We're going to start out by doing something that is directly applicable to what we'll be doing for your homework, or your lab rather. So module 2, so to get to the exercise, you can go directly to Runestone and go to exercise 3, or you can go to module 2 overview, right, project 3, not exercise 3. So you can go to the module overview, and you can click on Thursday will be a longer exercise down here, where I've got a direct link to the exercise over here, which is input, output, compute, which is basically what you're going to be doing for like all of your assignments essentially for this lab. Okay, so again, go to module overview. Let's see. Going to pause for a sec the recording because I didn't want to accidentally send a bunch of screen names on Discord. It does its best to kind of protect that anyway, but I just want to make sure that, I try to be conscious of privacy things. All right. So today's exercise, again, if you're on Runestone, the other place you can find it is you go to the textbook, scroll all the way down. It's how many handshakes is the exercise over here. So like I mentioned on Tuesday, Python can be used at this point for you like a really complicated and powerful calculator. And part of why I enjoy teaching this class is because I'm not just teaching you how to program, I'm really teaching you also how to take problems and solve them. Because that's a really necessary skill in programming. You need to be able to take large programs or large problems and break them down into smaller tidbits. And sometimes we might need to, and this gets into more advanced problem solving, but sometimes in order to solve a problem, rather than going, I have no idea, we just need to make some assumptions and just run with it. Okay? So for all the problems we do in this lab, you're essentially following this paradigm of input, compute, output, where we ask the user for some data, we use that data to compute something, and then we print out the answer. So this is an example of a program right over here. Okay? So in this one, if we run it, it will say, so let's look at this before I run it. Years is equal to input. Enter a number of years, and I'll tell you how many minutes that is. So right there, it tells you what the program is going to do. It's going to take user input, and it's going to, the end goal is to take a number of years and calculate how many minutes it's going to be. Now, if you remember, it seems very similar to what our problem is for homework, right? Our homework is take the number of seconds and figure out how many hours, minutes, and seconds that is equivalent to. Okay? Years is equal to input. Line 2, years is equal to integer years, right? So I mentioned this yesterday, and now we get to see, on Tuesday, not yesterday, and we get to see this in practice. When you take input, you get it as a string, you get it as a bunch of text, but you can't do math with text. So we are going to take that text and convert it into an integer to work with. Now, as we operate, if I were to enter 1 year, the word 1, it's hard to see because it's super tiny, but if I were to type 1, right, it would error out. It says I can't convert a string like that, a non-numeric string into a number. For this class, until lab 6, until otherwise specified, you can assume that the user is going to play nice, right? You can assume that the user, if you ask them for an integer, what they're going to do is that they're going to enter an integer. And if they don't, it's their fault, right? So here we convert it in. So here it's going to ask for something, then we're going to convert it. Next, to get from years to minutes, what we do is that we got to basically we need to convert down through the units. It's easier to do it slowly rather than all at once. We can convert years to days. And we're going to simplify and say years 365 days. So years times 365 is equal to days, right? So if I enter 2 years, it's going to be 2 times 365, which is 730, I think. So then if we do and then we take the number of days, we can convert that into hours, right? We've taken the years, we've converted it into days. We can take those days, multiply 24 to figure out, okay, X amount of days is equal to Y amount of hours. And we just store that in hours. And then we can convert the hours to minutes, right? Rather than doing this one keystroke at a time, like manually on a calculator, we tell the computer what steps those would be, and then it can automatically do it for us. So here I'll say 1 year, and it will print out 1 year is 525,600 minutes. Now, how to get that? It took years multiplied by 365. Okay, and then it took 365 and multiplied that by 24 to get the number of hours that was. So 365 times 24. And then it took 365 times 24, whatever that giant number is, and multiplied it by 60 and you got 525,600 minutes. Okay, so we have three parts to this problem, and the important ones are problem one, part one, and part two. Right? Part one says, hey, why don't we modify this, take this program and modify it to compute the number of seconds, right? Let's go ahead and figure out how to do the number of seconds, right? So instead of making it, say, print out how many, 1 year is this amount, or 10 years is this many minutes, which is 5 million, right? It's 10 times what our previous answer was. Or maybe let's go with 111 years. Rather than getting the number of minutes, what we're going to do is we're going to ask for the number of seconds. We're going to modify this. And again, and so as you hit save and run on this, as you make changes, right? Suppose I delete this space here just to get rid of that extra space. Right? As you make changes, if you accidentally mess up your program too bad and it's all a tangled mess of spaghetti that you can't really untangle, you can always rewind, right? You can always use this to rewind. It will have the original and then a snapshot of whenever you made a change and hit run. Okay? So go ahead and take maybe 5 minutes to try that on your own. For some of you, this will be really easy. For some of you, this is going to be really scary because you have no idea what you're doing. But feel free to work with the person next to you. Okay, I'll be going around trying to help people as need be, but for right now, take 5 minutes and try to solve it on your own. So this is the way that things will typically work in this class, where I'll give you a small chunk, and I'll give you a small chunk of time to solve it, and then once that time is over, it doesn't make sense to move on without actually addressing it. So again, like I said, for these in-class exercises, I will basically be giving you the answer most of the time. Okay? So for here, let's look at this part. So change the above problem to print the number of seconds. So first off, let's go ahead and change this input statement just to update that. If you didn't change that, that's not a big deal because it's the prompt. Enter a number of years and I'll tell you how many seconds that is. Now, what we've done here is that we're doing a lot of conversions. We're taking the years, we're asking and figuring out how many days that is. Then we're taking the days, figuring out how many hours that is. And then we're taking the number of hours and figuring out how many minutes that is. So for this one, we follow the pattern of conversion, right? We're going down from smaller time, from larger time unit to smaller time unit. So over here, we got to follow the pattern. Seconds is equal to, because we want to figure out how many seconds a year is, right? We take the number of minutes and then multiply by how many seconds are in a minute, which is 60, right? Yeah. Which coincidentally is the number of minutes in an hour for some reason. I do not know why that our time unit is broken up into groups of 60, but then there's 24 hours in a day, right? Not sure why it's not metric or something like that. What? I don't know. I know more about calendars than I do about time, if that makes sense, right? I know more about calendars than I do about time, so it's a question now I need to look up. So anyway, we've converted it into seconds, but now we need to print out our answer, right? And you may have forgotten to do this part, which is a mistake. If you forgot to do this, congratulations, this is a mistake you will make a lot, where we do the work, and mostly it's along the lines of doing something like this, where you do the work and then nothing prints out because you forgot to add a print statement in the first place. Or, as in this case, you make some changes and then you forget to change the print statement to print out your changes, right? So we'll say seconds to get the number of seconds and then seconds. So rather than printing out 525,000 now, enter the number of years and I'll tell you how many seconds that is. 1 year is equal to 31 million. Okay, 31 million seconds, 536,000 seconds. It's a lot of seconds, And it feels also depressingly like not enough.
Do you have to change the first years and the first line for the input for that?
I changed it to enter a number of years, and I'll tell you how many seconds that is. So I changed that from minutes to seconds because we're still taking in the same unit, right? We're still taking in the number of years. We're just changing what the output is. So the next step is where we are going to have to change that from years to seconds, though, because we're going the other way. So the problem now is change the above problem to go the other direction. Given a number of seconds, how many years? So this one is actually a bit of a jump because we have to use that operator. The proper way to do this is to use an operator that you haven't had any experience using yet, which is the modulo operator. So we're going to start out slow. I'm going to change the problem. When a problem's too difficult, you change the problem and then start building and then make it more and more like the problem you actually need to solve. Enter a number of seconds, and I'll tell you how many seconds that is. Well, we would know how to do that. You just simply print out, right? If I were to do that, and again, don't feel free to, we're going to have to delete pretty much everything for this one, at least to start with, because guess what? We're going to be going the other way. So enter a number of seconds, and I'll tell you how many seconds that is. Right? I know it's a little silly, but might as well start out. But I accidentally stumbled on starting out there, so we might as well start out there. So print out seconds. Seconds is, gosh, and the more I look at the word years, the weirder it looks. Isn't that weird how you can look at a word more and more, and suddenly you're like, why is it spelled that way? Okay, so enter a number of seconds. I'm gonna enter in 400 seconds. 400 seconds is 400 seconds, right? It's a very, it's one of those self-truths. Axiomatic statements, that's the word, axiomatic. Okay, so now, since we're trying to get to years, it doesn't really make sense to do it all at once. Let's figure out how many minutes that is, right? So, how many minutes? So I mentioned we have to use modulo, but that's going to come in at the end, by the way. So how many minutes? Okay. How many seconds are in a minute? Yep, 60. So what we need to do is figure out, if we want to convert this into, so let me change the problem prompt, enter a number of seconds, and I'll tell you how many minutes that is. We're working our way up to years. So we take in the number of seconds, right? So if there's 60 seconds in a minute, then what do we want to do to seconds in order to convert it to minutes? Divide, exactly. Number of minutes is equal to seconds divided by 60. For right now, I'm just going to use a regular division, okay? For right now, we'll worry about, and again, part 3 is doing, is the part that we're working up to, where we'll change it up. But right now, we're trying to convert it and say, how many seconds is that? How many years is that? So seconds is equal to minutes. Minutes. Okay, so now I can say 100 and, let's go with 150 seconds is equal to 2.5 minutes, right? 2.5 minutes, right? 120 seconds is 2 minutes. 30 seconds more than that would be half a minute, so 2.5 minutes. So let's keep going. Now we convert the number of minutes into hours, right? Hours is equal to how many minutes are in an hour? Right? 60 minutes in an hour, right? So what we need to do now is we do the same thing to convert. So since we're going from a smaller unit to a bigger unit, we're dividing, right? We're asking how many. So, and just simply to check the math mentally to yourself. Okay, if I've got 120 minutes, how many hours is that going to be? 2. How did I get there? Well, I divided by 60. That's how you got there. So minutes divided by 60 gives you the number of hours. Okay? So now if I go to 1200 seconds, it's going to tell me it's 20 minutes. Now, once again, I made that same mistake I said you're going to make all the time, which is I've taken, as I added new calculations, but I didn't update my input or output to correspond to that. Enter a number of seconds, I'll tell you how many hours, and then I'll print out how many hours that is, right? Okay, and so hours is equal to, so if I put in 2,500 seconds, it will tell me that's 0.694 hours. If I put in 5,000 seconds, it will give me 1.388 hours. It doesn't matter that we've got a repeating digit or anything like that. It's fine because we're just doing the conversion right now. So see if you can go the rest of the way to years. Follow the pattern we have, right? We're doing the same thing we were doing for the last one, right? And as a reminder, you can go and look what that last one was by using the timeline over here, right? And we're just going the other way, and instead of multiplying, we're dividing. So take a few minutes to do that. Okay. Hours is equal to, so over here, what we do now is what we're trying to do is build up into years. So I'll go ahead and change my input-output first to reflect what I want to do. Years, not years, I'm a snake. Years. Enter a number of seconds, and I'll tell you how many years that is. So we're here with hours is equal to minutes divided by 60. So then we want to take the number, so then the next step is to figure out how many days that is. Days is equal to hours divided by 24, because there's 24 hours in a day, right? It's just doing the reverse of what we were doing, which is we multiplied by 24 when we were going from big units to smaller units. Here we're going from a smaller unit and we're packing them into bigger and bigger units. And then years, again, we're oversimplifying and defining, this number of days. Well, if we have 365 days, that's what's equal to a year. So what I've done is I figure out I convert from seconds to minutes. We convert from minutes to hours, hours to days, days to years, and then we print out the year. So 525, what was it? 300. 525, 300 is 1.6, 500. See, is that too many? Hours, minutes, hours, days. Let's see. Let's go ahead and just enter this in and say, that was minutes, that's right. So 1 year is, so if we have seconds, we'll give 1 year is this many seconds. And if we go into this many seconds, that gives us 1 year. Now, if I were to say, though, that, let's go ahead and change this from 31 million something 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 to 40 million seconds. How many is 40 million seconds? So that's 40 followed by 6 more zeros. And it says that is 1.26 seconds. 40 million seconds is 1.26 years. So now the issue is that I don't know what that means, right? That's not a meaningful, 0.26 years is not a meaningful unit for humans, right? Because of the way our months and system, because the way we divide things into months and days, right? Because we're not dealing with, a base 10 system for years. We're just dealing with, like a metric system. Instead, we're doing, these weird units that have different conversions instead of being powers of 10. So I don't know what 0.26 years is. So part 3 asks, enhance part 2. So you print out the number of years, months, days, and minutes, right? So what is it asking? It's asking, rather than printing out that's 1.26 years, I'd like to say that's equivalent to 1 year and 70-ish, 1 year, 80-ish days, whatever that number is, right? 1 year, no, 90-ish days. And then how many hours and how many seconds? I'd like it to drill down into the actual time units, rather than giving me this leftover bit that doesn't really tell me anything, right? So the way we need to do that is by using the modulo operator. Now what we're going to do over here is, I'm just going to change this into number. I'm just going to delete this so that we can keep it, so I don't have to keep changing this part. And again, I'm going to restart kind of. Okay? Minutes. Okay? So I'm going to lead you through this last part rather than having you do it all by yourself. Okay? So seconds is equal to input seconds. We're going to get a number of seconds. And what we did last time is we can convert that right now into a number of minutes. Right? If I say it's 80 seconds, it's going to say it's 1.33 minutes. But the point is I don't know what 0.33 minutes is. If you think about it for a bit, though, you realize, that means it's a third, which means it's a third of a minute, which means it's 20 seconds, right? But you had to convert it into that 0.33. You had to change this floating point bit over, right, in order to figure out what this number of minutes was. You had to convert it to seconds in order to get something useful. So instead what we're going to do is we're going to make use of first integer division. So if I change this to integer division, which says given an integer and another integer on both sides, given whole numbers, my answer is also going to be a whole number. So if I do 80 seconds this time around, it's going to tell me 80 seconds is 1 minute. Okay? And it will do that until I enter something like 130 seconds or 120 seconds, in which it will tell me it's 2 minutes. Right? It throws out that floating point bit. So what we're going to do is we're going to take the what's left over, okay, and print that out. We're going to take what's left over. We're going to take the remainder and print that out. So here, right, what I'm going to do is I'm going to create another variable called seconds let's call it rem for remainder. Seconds rem is equal to seconds, or actually, no, we can just reuse seconds. No, I'll use seconds remain. That would be an issue. Seconds underscore rem for the remainder is equal to seconds mod 60. Modulo, remember, when we do, remember, let's go and, what's it called? All right, whiteboard. Okay. Okay. 1 second. So we go to our whiteboard for a second, and I don't need a template. Excuse me, got it right. Don't need any of that. Right. So if you remember, back in when you were in elementary school or middle school, you would have to do division like this, where you would say, okay, 135. Give me a second. 135 divided by 60. What you would do is you would do something like this, right? You would say, okay, 60 goes into 130 twice to create 120, right? Subtract 120 from that, what you have, and you'll have 15 left over, right? And then we can't divide that anymore, so that becomes the remainder. R15. 2R15. Okay? So, what I'm trying to say here is that divide gives you this. Modulo gives you this, the remainder. Modulo just gives you the remainder of that division operation. So what we can say is So we can say seconds is minutes, comma, seconds remainder seconds. And comma here. You can just kind of group things together without having to convert them if you just separate them in commas like that. So now, watch what happens. If I put in 130 seconds, it will say 130 seconds is 2 minutes and 10 seconds. Why? Because what we did is that we did integer division here, and then we just simply printed out what was left over. Okay? Okay. So now, what we need to do is kind of build up from that. And that's the tricky part, right? That's what you have to do for your homework. Okay? So we have 130 seconds is 2 minutes, 10 seconds. Now for your homework, what you need to do is build up to hours. So how do we do that? Well, it's the same kind of deal. The number of hours you have, right, is equal to, well, how many minutes are in an hour? 60 minutes in an hour. Minutes divided by 60. So you take the number of, oh, and one more thing. The reason I do this division here, right? The reason I do the integer division rather than singular division is if I did 130 over here, my output would look like this. 130 seconds is equal to 1.26 minutes and, 1.216 minutes. 130 seconds is equal to 2.16. Words are hard. And 10 seconds. And that's not right? Because what this is, that little floating point bit is 10 seconds. So we don't want that included in our answer. That's why we do the division over there. 130. There we go. So hours. Hours is equal to minutes divide 60. So now if I enter 5,000 seconds, it's going to say it's 1 hour, 83 minutes, 20 seconds. Not quite right? Because what I've done is I've taken the number of hours I've had, I've divided and figured out, okay, 83 minutes is, I had 83 minutes, that's equal to 1 hour and a bit, right? Right? 5,000 seconds gives us 83 minutes, which is 1 hour and a bit extra. So instead we want to get rid of that, we want to render that a bit extra. Minutes is equal to, so we could either say minutes, but I'll follow the pattern I've already done. Minutes remainder is equal to minutes mod 60, and this statement is going to get annoyingly long. So instead of printing out the number of minutes, we print out the remainder after we've divided. Make sense? So instead, what we do is we do 5,000 seconds. And 5,000 seconds is 1 hour, 23 minutes, and 20 seconds. Okay? Where did I lose people? Okay? And probably when I started introducing this, right? So minutes is equal to seconds divided by 60, right? We convert the number of seconds we have into a number of whole minutes, not fractional minutes, right? 60 seconds is equal to 1 minute. 70 seconds is equal to 1 minute and a bit, but we're throwing out that bit. We don't want it. Then we take that same number, 70 seconds, and ask, okay, how many seconds would be left over after I figured out how many whole minutes that was? So 70 seconds, the mod 60. What is the remainder of 70 after you divide by 60? It's 10. You can figure that out, believe it or not, by doing subtraction. 70 minus 60 is equal to 10. That's how it figures it out. And so that's what we're going to print out for seconds, and so we print out the number of minutes. Then when we add hours, what we do is we figured out how many whole minutes we have, and we converted that into hours by dividing by 60. Okay? And then we figured out how many of those not whole hours we have left over, right? Here we had 83 minutes total, so we asked ourselves, okay, we had 83 minutes, I tried to convert that into hours, I didn't convert that fully into hours, right? So I'm going to take 83, mod it by 60, because that's because we divided by 60, that got us the quotient, mod by 60 to get the remainder. Seconds is equal to hours. And I'm running out of time. So we just keep following the pattern here. We go from hours to days. Days is equal to hours. There's 24 hours in a day. Mod 24. Hours divided by 24. Hours remainder is equal to hours mod 24. And then finally we do years is equal to days divided by 365 days in a year. And days is equal to however many of those that are left over. Or rather, days underscore remainder. You could, reuse the variables, but I'm trying my best not to. Over here, years is equal to, so days remainder is equal to that. So now what we do is we would just simply say days, comma, days, add that in, and then add years, comma, years. We don't need a remainder for years since that's our biggest unit. Days rem. But we could go up to decades and stuff like that. And now if I enter 40 million, we find out that 40 million seconds is 1 year, 97 days. That's a bit too many hours. Where did I mess up? Hours remainder is equal to mod 24. Oh, I just didn't print out. I didn't print out the remainder. I printed out how many hours we were using. Okay, hours. So let me try this. 40. And 97 days. Days remainder. Did I do that? Oh yeah, 97 days is less than 365, so that's appropriate. So 1 year, 97 days, 23 hours, 6 minutes, and 40 seconds. All right, so done with this program. I'm going to move on. Wait, Professor Rosen, that's too much. I'm trying to copy it all down, and I can't. So pretty cool button over here I have as the professor. So all I have to do is hit this, and you're about to share this code with all your students. Are you sure you want to continue? And I hit OK. Oh, I must be logged in to share code. I'm not logged in. Pretty sure I am logged in. That'd be weird if I'm not logged in. Yeah, I'm pretty sure I'm logged in. Interesting. Okay. Pretty sure I'm... And there we go. What do you mean I must be logged in to share your code? That normally works. Okay, that didn't work. So, alternative number 2. The backup plan. I'm going to dump it on Discord. Which all I have to do, and it's pretty cool how I can do this, I can denote that it is Python code. Boop, boop, boop. And there it is on this. Yeah, where is, oh no, it didn't denote it was Python code? Why didn't it go and say it was Python code? Should have said, or do I have to say Python 3? Go. And there you go. So, okay, only 20 minutes left, so probably only enough time to work on this one. How many trees? So, the tech industry used to give really terrible interview problems. Things like, how many houses would fit inside the Empire State Building? They'd do that as an interview question or something like that, or how many gallons of water pass out of the Mississippi River every day, or how many trees are in the state of Washington. questions that you should not, that nobody, except for somebody who, is a trivia person and and was really bored on Wikipedia one day, would know the answer to. But the thing is about those weird interview questions, which they don't ask anymore. Now they focus on fundamentals like data structures and algorithms, which is honestly the best way to do it. What they're looking for is something that's honestly not taught in school, or not necessarily explicitly taught in school, and I'm going to try to do my best to teach you a bit of it here, is they're looking for the problem-solving process rather than the answer. How do you go about getting to an answer to a question like, how many trees are in the state of Washington? Right? But, and the thing is, nobody knows the answer to that question, but we've got techniques for guessing it. And this is where, again, using our computer as a big calculator can really come in handy for at least recording our steps. We could do this with a calculator, but doing it here allows us to, do an overview of the steps. How many trees are in the state of Washington? Where would we even begin with this? Well, yes, did you have an idea?
I was going to say find a favorite area for the trees, find the area of Washington, and then figure out how much of Washington is like buildings versus.
Yeah, that's exactly it. We'd probably want to figure out, okay, we can make a gross estimate, but a very educated guess by figuring out how big Washington is, figuring out how much trees is in a tree-heavy area, right? And then figuring out how much of Washington is trees, right? So let me go ahead and I'm going to go and open a private window so that I don't, give you, like all my personal information, like my address and stuff. So let's go ahead and just open up Google Maps and zoom out, right? And we'll go across, and again, it's asking for the state of Washington, not Washington, D.C. Now, here's the thing you may not know if you're on the East Coast or not from the U.S. A lot of this area is actually very rural, very empty. There's a lot of space here, and there's a lot of forest. A lot of desert too, but a lot of forest and a lot of plains. So Washington itself is fairly northerly, and we can look at, and this is a, abstracted map, but so let's go ahead and look at a satellite view of Washington. Okay, that's green area, we can safely say that's tree, okay? And we can say that this area, where there's either farms or there's city, right? Cities, here's Spokane. It probably has some amount of tree, but it's not really much in the way of calculation, useful for our calculations. So like eyeballing it, percentage-wise, how much of the state of Washington would you say is forest? 60%? Anybody want to say anything different? Because there's not a wrong answer here. It's making guess. I would guess, yeah?
I'm going to go with
80%, really. My personal guess based off of just looking at this is I'm going by half, essentially. But 60 also makes sense based off of we've got this bit over here. So 60, 50, somewhere above 50 is probably the correct answer, right? A lot of this is green, right? As long as you're above 50, we're in the right thing. So we know how big Washington, we know how much of Washington is forest. So now we have to make two more kind of facts, one of which we can look up, right? And is pretty easy to figure out because we can look it up. How many square miles is Washington, or possibly whatever unit we would need to know, which is either square kilometers or hectares. Why? Because when you're dealing with forest stuff in the U.S., sometimes a lot of stuff is in acres. So, but figuring out how big Washington is, okay? And then once we figure out how much Washington, so let's go ahead and let me write this down in our, so what we're going to do is we're going to figure out percent trees, okay, is equal to some number, right? Let's go with the original guess, which was 60. Doesn't really matter, 0.6 or 0.6, 0.60 doesn't really matter. Size of wash, yeah, size of state, size of Washington, or just maybe whatever variable you want to call it, is some number over here, which I will just denote as a bunch of x's for you to fill in, right? And then what we do is ask trees per size, where size is some number of units, right? We don't know what units you're going to use, but what you want to do is we've got 3 facts here. We've established 1, or guesstimating on 1, right? Size of Washington is the only thing that's going to be exact here, right? Which is how big Washington is. And then finally, trees per size. So take about 5 minutes to look those up. And then what we're going to do is what you do after that is you say percent trees. You can get your answer by saying percent trees times the size of Washington times how many trees per whatever that unit is, trees per size, assuming you can spell per as opposed to saying pre. Okay? So go ahead and take 5 minutes to kind of look at doing that. Okay? And yeah, go. And this is one where you'll want to use Google or whatever search engine you prefer to figure out, like, okay, what are facts about this? ChatGPT might actually be useful here, except for, just don't look up how many rocks you're supposed to ask it how many rocks you need to eat a day. It will tell you 1 rock a day. True story. It accidentally read an Onion article, which said to do that. It's pretty funny.
Wasn't there a really bad one where, like, if you look up suicide prevention on Google, there was a time where, like, AI brought up articles of those people with size.
That would not surprise me. That would not surprise me at all. It's a lot of tech companies do love to rush stuff out the doors as quickly as possible. Oh, yes, this is on, nice. Somebody was kind and added batteries. All right, give it a couple more minutes. All right, anybody got an answer yet? Yes.
We're missing a float.
We're missing a float somewhere? Which one?
Let's see. Like our float object cannot be interpreted as an integer on line 4.
On line 4?
Yes.
Did you replace these with numbers?
Yes, I did.
Let me see what you got.
I don't need a column.
That's it.
There we go.
So what's your estimate?
Oh, I put a comma.
Yeah, well, what so anybody got an answer?
There 3,211,290.
Well, that seems low. Yes.
Okay, so I have the same problem, but it says float object
Did you use a comma instead of a period? Anyone? Yes. 3.3 billion. Now we're talking. All right. 1.5 billion. So how did you get 3.3?
I looked at the number of forested acres in Washington.
Okay.
And I predicted that there's around like 153 per forested acre, and I used that metric.
So 150 trees per acre in the forest. Yep. And your estimate was? Well, yeah, you. And you got that with?
I said that there's 34,375 trees per mile, and I multiplied that by the square miles of Washington.
Excellent. Yes.
I think I got
1.6 billion. Yeah. You're in this. Billions is the right order of magnitude to be in. Yes. So, and you got that, and how did you, and what was your unit for trees?
I looked up the amount of trees in a kilometer for the U.S.
Mm-hmm.
And then I converted it was in kilometers, so I converted it to miles.
Right.
And so I got around 38,000.
Mm-hmm.
And I got the size of Washington and
Excellent. Yeah. So a lot of these, what these people were saying, if you couldn't hear, was that they looked up how many trees per acre, or how many trees per kilometer, or how many trees per square mile, right? And then multiplied by that same unit for the total size there. And then they, and then once you multiply that by your percentage for trees, you'll get one answer versus another. And it really does depend, because it's the average for the U.S. versus the average for the West Coast, right? Which might be a bit different because that's a different climate. All right. So this is a useful problem-solving technique, and it's all based off of these kind of assumptions, whether or not you do this. So I don't think I have time for how many handshakes, which means I don't, since I see people rearing to go since it's 3:14. But this last problem, let me go ahead and just cover it really quickly. How many handshakes? So it's asking you how many handshakes are all the people in your class. So we've got it's asking so this problem asks how many handshakes would it take for everyone in the class to shake handshakes with everybody else. You should not shake hands with any person twice, and you don't shake your own hand. So when we get to math problems like this, the key is to look for patterns, okay? So one person shakes hands with nobody, right? You don't shake hands with yourself. If you've got two people, there's one handshake because the two people each shake hands with each other. Make sense so far? So now let's say we've got Alice, Bob, and Carl together in one class. That's three people, Alice, Bob, and Carl. Alice shakes hands with Bob and Carl. And then Bob and Carl shake hands with each other. Right? Then suppose we add Dan into the mix, right? So we've established already that Alice needs to shake hands with Bob and Carl, and Bob and Carl shake hands with each other, and then we can ask Dan to shake hands with everybody else, right? And handshakes are, if Alice shakes hands with Bob, it's the same as Bob shaking hands with Alice, right? Two people shaking hands, it doesn't matter who shakes each's hand. So 2 + 1, and then we added another person to the mix, 3, 4. And so if we added Edgar to the mix, basically we'd use the same answer we had, right? If we had 4 people shaking hands, they would shake hands with 3 people, plus 2 people, plus 1 people. Or 4 people shaking hands, they'd shake hands. There would be 3 handshakes for one person, 2 handshakes for another, and then 1 handshake for the last pair. Adding another person in, that 5th person needs to shake hands with all 4 other people, right? Is equal to 4. So add 4 to that. I'm sorry, add 6. Did my math wrong here. 10. Adding a 6th person does 5. We add 5 plus 4 plus 3. That 6th person has to shake hands with 5 other people. 15. And this actually, for me, that's enough to know exactly what this is, because I have too much free time on my hands, and I know that's the triangular number series. Which is one that you'll come across a lot in computer science, which basically means that, all right, looks like people are getting ready to go. So, for this one, believe it or not, if you've got 250, so I'll skip to the end. If you've got 250 people, then the number of handshakes you'll have is, let's see, I believe it is print 250, sorry, x times, no, it's x times x plus 1 over 2, except it should be x minus 1 because we're doing one less, because you can't shake hands with yourself, which would be 3,100, sorry. So a lot of times when you see this, you see if you can come up with an equation that matches this. In this case, this equation that I used, run it, is one that I'm very familiar with. Don't have time, obviously, to go into it. But like I mentioned, it is the triangular number series, which has a very well-known formula. And a lot of times you can just plug a formula into Google and it will tell you what that formula is and what the sequence is and how to get the formula to describe it. Give me 1 second. All right. So take care.